I'm Jerry Tyson of Arl Madison Associates. In this video, we're going to be talking about a new product from Parker, the ACR74T. It's a new drive controller package for stepper motors. This particular version can control up to 4 axes of stepper motors, with or without encoder feedback. Let's take a look. Here's a unit next to a NEMA 17 stepper motor. I even put a quarter in between to give you an idea just how small this unit is. You can see on the left-hand side the 4 encoder inputs. On the right-hand side, the 4 motor power outputs. At the bottom on the left, you have the control power input, and on the right, the main power input. On the top of the unit, you have the Ethernet port and 2 26-pin I/O connectors. This unit has 20 inputs and 8 outputs, and 1 motion enable input. By the way, that motion enable input has to be pulled up to 24 volts, which is available on one of the other pins on that same connector, in order to enable the... Okay, let's take a look at the software. The software that you need for this product is Parker's Motion Manager. It's a free download from their website. Once you've downloaded it, installed it, and run it, you will see this splash screen. You'll click on New Project. Give your project a name. You can change the location where it's stored on your hard drive, and of course set the IP address to what makes sense for your network. And choose the controller. Currently, it's just the different axis variations of this controller that's available. Then click OK. It will create a tree structure on the left-hand side and give us a connection screen. So now you can click Connect. And you can see down here at the bottom, you get a message saying your connection controller succeeded. Now go up to the Configuration Wizard and select Axes. Here you can set the alias for the axes, and you can turn off the command output if you choose. In this particular setup, I only have 1 axis, so to make the configuration clean, I'm going to cut off the other 3 axes. This is also where you would set which master the axis is tied to. Click Next. You can rename the master if you like. Then choose the units for your application. In this case, we're going to go with degrees since we don't have a transmission. Let's set up some defaults for the master motion. Now we're going to set up the parameters for the motor and the drive. In our case, we're going to be using the ECLM motor. The one that I have is the S172F. And then from the database, we'll fill in the appropriate numbers. You can set the drive resolution and of course the current settings. You also have the ability to invert the motor direction if it's not proper for your setup. Next, this is the setup for the encoder. We're using the built-in encoder on the ECLM. You also have the advantage of setting up an external linear encoder if you'd like. Now let's look at the scaling. Since we chose a unit of degrees, it's going to limit us in the transmission to a choice of none or rotary table. Had we chosen a linear unit, we would have choices of ball screw, belt drive, and other linear transmissions. In this case, we're going to choose none. We also have the ability to choose a reducer, but in my case, it's none. So now we have 1 motor revolution is equal to 360 degrees, which is perfect. Here's where we enable the positive and negative overtravel limits and define this deceleration that occurs when you hit the limits. You can assign them to different inputs, and this is also where we define the home limit and its type. The software limits are defined here, along with the maximum position error. Here we define the memory allocation for the controller. You have 16 programs, labeled 0 through 15. You'll notice the last 2 are reserved for the scopes, data, and the configuration source. You can set the memory allocation for each program individually. This is also where you set the memory allocation for your global variables. Notice that you have up to 1 megabyte of memory to work with. Now that we're done with the configuration wizard, you'll click Finish, and it will download all of the configuration, defines, and programs that are set up when you click OK. Okay, now it's going to show us the system code that was generated by the configuration wizard. So this is what gets put into program 15. The configuration source, the XML, is shown here too, but in most cases you'll never have to work with that. So we move on to the program editor. Defines is where you set up the names for your variables, and then your program editors are all here in order, 0 through 14. Next we have the terminal emulator. This is where you type commands directly to the controller. For instance, we can check the version of the firmware by typing VER. You can see we have version 7.48 on this system. Now let's look at some of the other tools that are available. You have the Jog Home limit screen for each axis. It's a great page for doing your debugging. It shows you whether or not you're communicating, if you've hit a limit, either hardware or software. It shows your position, if your max position error has been exceeded, also if the motion enable input is active or not. You can see the legend down here, red is not ready, green is ready, yellow is error, and gray is inactive. So you can see right now the drive is not enabled because it's red. So if we hit this button to enable the drive, you can see it change to drive enabled and turn green. Now let's do some jogging. First thing we have to do is set up the jog parameters. So let's set a velocity for 360 or 1 rev per second. Let's set an X cell for 36,000, a D cell for 36,000, and we'll leave jerk at 0 for now. We can now jog both positive and negative. Here, let me show you what it looks like on the actual motor as I'm jogging positive and then jogging negative. So, very simple way to get motion on your. Next, we have a page for updating the firmware. You can always download that new version from Parker's website. Then we have the status panels. These are great panels for quickly looking at data. The motion panel shows you the motion status for all the axes in one nice convenient place. The drive panel, the drive specific information. The numeric status lets you look at pretty much every parameter inside the controller from here that is numeric based. You'll see next we have the bit status panels, which is the same thing for all of the bit flags. And there's lots of data here to go through for all the axes, and it's very convenient to be able to get to that quickly. Then comes the scopes. So you have an oscilloscope built into the system that allows you to scope all the data we just looked at in real time, so that you can do debugging and proving that your motion control system is reaching the requirements of your application. So you have two identical scopes that you can set up and switch between, so you get chances to look at lots of data. So thanks for joining us on this tour of the ACR74T. Stay tuned to this channel for more videos on the ACR74T and other exciting new products from Parker. Take care.